Hi everyone, welcome to Machine Learning with Python. This is part of the PG diploma in AI preparation, whether it is on CDAC or it is in any other JE or whatever, you can use that. So this is our uh, ML with Python. So this we just focus today on machine learning as a revision of what we have been doing. And Jamit Wasawa is there and CG is there. And we can discuss while we continue. So I'll hand over to study circle lead Jamit Wasawa. Thanks, Jamit. Go ahead. And we try to wrap up in 15 minutes. Thanks.
So yeah, thanks a lot for the intro, and so welcome everyone for the machine learning with Python's first introductory short and sweet session. So what is machine learning, and uh, how do you perceive it, or how do you use it as it's really getting really common nowadays. So what is an artificial intelligence first to begin with? So it's an ability for a computer to mimic the intelligence of the human. You can see it various different parts, which are ML and DL, stands for machine learning and deep learning. DL being subset to ML being subset to AI. In ML, or machine learning, we have data sets to train the model first on a specific task, and uh, have the desired results, and train it and improve it until we get the desired results. Next, we have the deep learning, which constitutes of more deeper uh, deeper insights into the problem and gives us the solution by including various or numerous other factors into it. So even though this is one of the way to showcase the relationship between AI, ML, and DL, as you can see in the Venn diagram, uh, there is a different opinion also that AI doesn't belong to ML and stuff, but that's a different uh, opinion by different people. So after AI, how is it used? How does a computer learns? So it if we move back a bit, then computers were used only to do stuff, do a specific task, and not have any intelligence behind it in a way. So those are how algorithms were used. And an algorithm was made. What is an algorithm? It is a set of instruction. So the computer followed a set of instruction and gave us the output that we desired. The way we use algorithm for ML or machine learning is that we try to improve the performance of the computer for a specific task, and that for what it was uh, designed for. So we are looking, when we talk about machine learning algorithms, we are talking about continually trying to improve it based on the use that we have employed it for. So you can see a very general use case of uh, machine learning, or how machine learning algorithms are used, which is spam email filters, recommendation systems in Netflix, Amazon, Pinterest, YouTube's feed and stuff, right? Then language translation services, which is Google Translate, image recognition software, and predictive analytics and stuff. Next is type of ML categories. So we have supervised learning, unsupervised learning, and reinforcement learning. What is supervised learning to begin with? It's as a it needs a certain kind of supervision. Why it needs a certain kind of supervision? Because in supervised learning, we already know the end objective and end result of it. But what we are trying to for for the machine model to learn is that to get to that end objective or the uh, already known goal that we have. So that's what supervised learning is for. We have a data set and we train the machine learning model on the data set and uh, try to improve it by training it again and again to reach to the desired level of efficiency. Next, we have a unsupervised learning. Sorry. So in unsupervised learning, we we have the data and we let the machine learning model itself learn the hidden patterns that can be present in the data and give us the insights from it. Here we let the machine learning model do its go on its own on the data to learn the patterns and give us the insights. Next is reinforcement learning. Uh, in reinforcement learning, the machine learning model will basically perform a task and learn the task eventually by trial and error method. So let's say there is a robot in a room, and after colliding with the walls of the room, eventually the model will learn the size of the room and the shape of the room, and it will stop colliding with it and learn the pattern of the whole room. So this is what reinforcement learning does is. Now the fourth one is a evolutionary algorithm. So what is it? It's a evolutionary algorithms are algorithms that imitate natural evolution to solve problem. Evolutionary learning is a method where computers try to solve problems by using techniques inspired by how species evolve and adapt over the time in nature. So ant colony optimization and generic algorithms are some of the examples to it. Now, moving further. So developing the machine learning models. So first, even if before these things, there are discussions that should be happening before we get to these steps, which are why are we building the model? What is the objective of building the model? Then how are we going to deploy? What is the scalability of the model? And how are we going to afford to deploy the model and keep it running and fit into the budget that was given to the team and stuff. So after those kind of discussion, we start by developing the machine learning models first by collecting the data from various sources. We collect the data and then we as I will be following the image here. So the data engineering step will be first considered, which is basically building a data engineering pipeline of getting the data from the source to us. Uh, Data engineering also involves ETL, which stands for extract, transform, and load. Extract means extraction of data. Transform means to uh, transform the data into the desired manner in a way what we want, as well as cleaning the data and stuff. Then loading the data into the place where we can continuously use it for our own use or whatever use case that we are using for. Feature engineering is there are so any data set contains different features, and not and we are only we are going to use certain features from the data set for our machine learning model. So feature engineering basically uh, is the features that are useful to us and have to be selected from the data set and to be used for the model. Now, choosing the right ML model from the category that we just discussed, and which aligns with our use case. So, after choosing the right ML model, we train the model on the data sets that we have stored or used, uh, stored in the uh, our storage for our use case and the use that we want to have from them. Once the ML models are sufficiently trained and are giving us uh, the desired results on the training sets, then after training and validating the model, we deploy them. There are various different techniques like catenary release, then A/B testing and stuff. So you can deploy the model in different manner and uh, keep on monitoring the model as well as evaluate the model. Monitoring for what can be something that can make the model to crash or stop working in a desired manner, and also to monitor what are the improvements that we can make while the machine is already deployed. And that is what evaluation and monitoring the model means. And keep on scaling the model as far as much as we can for the given data or the changes in the data that are happening with time. So for the so for the implementation of these models in the field of artificial intelligence, Python has been a really dominant language for being chosen for various kind of reasons. Uh, as Python was first um, designed for children to learn coding and stuff. It was really easy. It was made in a really easy manner. But because it was easy to use, some of the experts started using it as well, and they used it in a very uh, variety of manners and to execute what they want. And it became famous, and it started becoming uh, being used for machine learning and stuff eventually. So some of the advantages that Python for machine learning and AI based projects uh, give us is uh, it is comparatively smaller code or smaller lines of code are needed to generate something than access to great libraries or variety of libraries that are present in Python and to be used for AI and machine learning. Then simplicity and consistency, as previously mentioned. Then platform independence and flexibility to use it. So as we are discussing Python related to the machine learning, these are the list of different libraries that are used in machine learning by Python. Uh, uh, so we have NumPy for scientific computing and linear algebra, then SciPy for mathematical, statistical, and engineering functions. Scikit-learn is another common and common library to be used. Then we have TensorFlow, library for deep learning and neural networks. Same as Theano. Then Keras. Then Pythos, a library for dynamic computation, graphs and tensors. Pandas for data analysis and manipulation. Matplotlib for data visualization and plotting. Then Seaborn and Stats model. So yeah, this is it for the introductory session for the Python. Later on, we'll try to get into more of the practical approach for it. So yeah, thanks for listening.
Thank you, Jaimit, for the introduction to the machine learning with a little bit of intro to Python too. As we move along to the later sessions, we expect to see some kind of maybe a notebook or some Python. You can use the notebook, which is a standards used for Python codes. So whether it is based on the cloud or whether it is based on your desktop, that's okay. Whatever you can uh, work out from your end so that it can be used. And we do have the recommendation on the books, uh, ML using Python. So what I would say is you can put those references in the slides later and share it in the what do you call the community. And this is a since this is open to all, we expect that session on Wednesday will introduce with at least Python rather than focusing on machine learning. We just focus on Python and see what types of uh, access we can use for Python. I know there are many in the cloud as well as in the home, whether you are using Anaconda or whatever. You can build your own stack and then apply it. You can also use one of the IDEs. There are plenty of them. So we can discuss about the various Python IDEs and what is there for inclusion in the course which we can use. And that is what we will focus on Wednesday. I think with that, CG, you have anything to say before we close? Go ahead.
No, no, that's all.
Okay, so what we'll do is I'll stop the recording and we will end the session one of the uh, machine learning with using Python. And then we'll look to the second session on Wednesday. And this is Monday, Wednesday, Fridays. And if it overflow to Saturday, just to cover some of the use cases, and this will be for another 4 weeks. So we should be ending this by June 1st week. And thank you very much. I'll stop.